Hello everyone, welcome to Chapter 9. In Chapter 9, what we're going to do is we're going to look at thermochemistry. And so this is sort of where the way heat transfers from one place to another. We're going to identify and convert between common units of energy like joule, calorie, and kilocalorie. Now, I may not do specific problems in this section, but we're going to talk about what those are and how you would do that, okay? Because this is something you're going to do with most of the problems in this section. So, a few definitions: energy, anything that can do work. And so energy is it can be heat, it can be work, it can be forces against things, and so the key thing is you're exchanging it between objects, and so you can do that like with collisions between molecules. You can do that pushing a bowling ball down a hill. So there are all kinds of things to do. So work is where you apply a force over distance. So energy, which is in the form of work, is force times distance. So how hard you're pushing times how far it's going. Heat is the flow of energy caused by changes in temperature, where you're going to trade off heat in one object to heat in another. And so when heat and work are together, you are in a multi-system kind of situation. So you could either do work in the form of heat or you could do it in the form of work. Work is in physical work. So kinetic energy is energy in motion. You've heard that forever, probably. Thermal energy is a form of kinetic energy where you are transferring energy from one thing to another, or heat in this case, and so you're going to see a difference in temperature. Potential energy is stored energy. Okay, so just like your parents told you have so much potential, why don't you use it? Okay, so potential energy is things you have that you may not be using. So potential energy is energy that's stored. Okay, and you can store it in an object, you can store it in chemical bonds as well. So when you have you're holding something up a certain height, you have potential energy there, because when you drop it, you're going to convert to kinetic energy because it's going to be moving. So energy, which is the capacity to do work, can either be kinetic energy in motion, and thermal energy, as we said, is a type of that associated with changes in temperature. Energy can also be potential energy, and this can simply be the composition of the molecule. What kind of bonds there are in the molecule? Are they high energy, or what? So, and then that can be converted into the chemical energy stored, and really the chemical energy is associated with your electrons and where are they? How far away are they from the nucleus? You'll have to think way back to like chapter 1 or 2, where we talked about the positioning of the electrons, and it took more energy to take one away than it did the other, depending on how close they were to the nucleus. So some forms of energy: you have electrical, the thermal energy we talked about, which are kinetic. These are kinetic, right? Light or radiant energy associated with the transitions within the atom. So your electrons, going up and then coming back down. Nuclear energy is potential energy that's stored in the nucleus of the atom. And then chemical energy is the potential energy stored in the structure of the atoms or the molecules. Kinetic energy can be calculated with the formula of 1/2 mass times velocity squared. Okay, that's kinetic energy, and that's used a lot in physics. Okay, because this is usually motion of objects. We don't really do objects a lot. We're doing molecular energy. When the mass is in kilograms and the velocity is in mass per second, that's going to be a joule. Okay, so a joule is equal to a kilogram times meter squared per second squared, also in physics known as 1 Newton meter. Okay, a joule of energy is the amount of energy needed to move 1 kilogram at a speed of 1 meter per second. The calorie, notice this is a small c, lowercase c, is the amount of energy needed to raise the temperature of a gram of water 1 degree C. If it's a kilocalorie, okay, then that's going to be with a capital C. Then that's how much it takes to raise 1,000 grams of water 1 degree C. So kilo is 1,000. So if you got a calorie, it's 1 gram 1 degree. If it's kilocalorie, it's the energy needed to raise 1,000 grams or a kilogram of water 1 degree C. That's the food unit calories that we're familiar with when we look at the caloric content of food packages. So the calorie, there's a few of these that are super important, and I'm just giving you these conversion factors. We already know how to do dimensional analysis, so I'm not going to do the basics, how many calories is in 5 joules or whatever, but you'll be able to do that because these are your conversions. So 1 calorie is the same as 4.184 joules, okay? 1 kilocalorie is the same as 1,000 calories, okay? 1 big C calorie, or 1 kilocalorie, is 1,000 calories. And then a kilowatt hour is something that you'll see in the States, okay? A kilowatt hour is equal to 3.60 times 10 to the 6 joules. So 1 kilowatt hour is equal to 3.60 times 10 to the 6 joules. So these are the conversion units of energy that you'll be using a lot, especially this one right here, the 4.184 joules. So that's just a little introduction to the conversions of the unit conversions and conversion factors of our energy.